Mexico City, one of the world's most polluted capitals. A brown fog from vehicles and industry hangs in an acrid cloud, stuck in the basin formed by the surrounding mountains. At times your eyes sting and you can actually taste the pollution. The city authorities have been forced to take strong measures. Vehicles have colour-coded permits, restricting them to set days when they can drive in the city. Despite this, a population of over 15 million means near gridlock most of the time. Alone, there are over 100,000 of these green taxis fitted with catalytic converters. Without the catalytic converters, permits and other emission controls, atmospheric pollution in Mexico City does not bear thinking about.
Here in Britain, controlling vehicle emissions is no less important, because every vehicle puts out waste gases, even though we can't see them.
Emission standards are part of European law, and they are generated in consultation with all interested European governments. Manufacturers can meet emission standards using a variety of different technological routes, but certainly we use data that's generated during type approval procedures. Now, these type approval procedures are very long and complex and obviously very expensive, and we can't generate those sorts of tests when we're doing an MOT test. So the test that we just use the values that they generate at type approval. That information is in a book called In-Service Exhaust Emission Standards for Road Vehicles, and we bring this out from time to time, and it's updated on a regular basis to bring in new models and to amend the data in light of experience. Certainly the booklet is part of British law. A vehicle manufacturer can't suddenly change the data in the emissions booklet. Any changes that are going to be made will be advised to you by the Vehicle Inspectorate, and changes should not be used without confirmation from them.
Emissions testing in the MOT test isn't usually thought of part of a strategy to help improve the environment, but that's just what it is. Emissions testing, though, with the many different machines designed for the purpose, isn't a matter of just sticking a probe up an exhaust pipe. So I need an expert, and I've called on my old friend Henrik from the Vehicle Inspectorate to tell me more. Hi, Henrik Cowie.
Hi, Sean.
Now, you've got a line of variety of cars here, but what's they all about?
Well, for emission testing, there's a great deal of information to take in, but there's a very simple way of getting through it all. In the manual, there's a flow chart. It really does work. It's a simple case of working your way systematically across that flow chart. As you do so, you begin to realise that all the petrol engine vehicles are split into age groups. So what we've done this afternoon is got one car from each age group, and what we're going to do is go along the line and have a look at the issues with each one. Let's start with this one here. What we've got is a car first registered before August 1975. This car only needs a visual test. But to do that, there's a few things in preparation. First of all, the engine's got to be warm. Once the engine's warmed up, we'd do what we call a purge. I'll refer to the purge later on. But a purge is to clear the inlet and exhaust systems, and what we do is run it at half revs for 20 seconds. After we've done that, we allow the engine to return to tick over. Now, tick over is another important point, because all of these vehicles will not have to have an excessively fast tick over. Even when we get right up to a catalyst vehicle at the other end of the line, they can't run excessively fast. So tick over is an issue. We've purged it, it's dropped back to tick over, we're happy with that. We'd walk down to the other end and look at the tailpipe to see if it emitted excessive blue or black smoke for 5 seconds after we've let it settle on. Now, there's one other thing we've got to do when we're happy with that, and that's what we call the acceleration test. So we're now going to accelerate it from tick over to half revs, and then we're looking for black smoke of a volume that would be hazardous to other road users. So it's a little acceleration test from tick over half revs, and it'd have to be pretty bad. Okay, let's move on to the next one. For this one, we're going to use the gas analyzer. It's a vehicle registered from the 1st of August 1975 up to the 31st of July 1986. We're going to get the vehicle fully hot. We're going to purge the engine for 20 seconds, let it settle back to tick over, not too fast. Look at the tailpipe, no excessive smoke. And then we're going to do that half acceleration test again, up to half revs, to see if it's excessively smoky. Now we're going to put the analyzer in, following the manufacturer's instructions, and test for those two gases. And they're carbon monoxide and hydrocarbons. The levels are in our friend the manual. You might have a vehicle which has met the CO test but failed the hydrocarbons. What you're permitted to do then is to raise the engine revs to 2000 RPM and recheck that the hydrocarbons are within the allowed level. Now let's move on to the next one. Here's a vehicle, again, with a gas analyzer the test is done. It's a vehicle registered from the 1st of August 86 up to the 31st of July 1992. This time legislation has lowered the CO limits, but apart from that, all the tests are exactly the same as the other one. On to the next one.
Now this is about in 1994, so what happens around then?
Well, it fits into the group of a vehicle registered from the 1st of August 1992 to the 31st of July 1995. So that means that when we follow that, you know, that diamond flow chart, the flow chart in the manual, we've got to resolve a couple of issues. The first issue we have to resolve is it a passenger car? And that's actually not as obvious as it might seem, because if a car has more than 5 seats in addition to the driver, it's not a passenger car. If a car's design gross vehicle weight exceeds 2,500 kilograms, it's not a passenger car. So there's a couple of issues there. Oh, and of course, goods vehicles, vans, motorhomes, they're not passenger cars either. So what the flow chart tells us is when it's not a passenger car, we'd do that 2-gas test that the last one got. If it is a passenger car, we move along the flow chart to the next thing that we've got to look for, which is an exact match with the database. So what we'd do is we'd enter the make, the model, the CC, and the exact engine code. Now they can be very difficult to find. There's a lot of help in the manual. It tells you where to look and what to do about it. But what you've got to do is get all of that data matched up with the database, either on your 96 spec analyzer or in the Department of Transport's emissions guidebook. Once you've got that complete match, you would then carry out a full catalyst test.
Now this vehicle's about in 1995. What's changed between 1995 and present day?
Well, the thing that's changed, Sean, is that for a vehicle registered from the 1st of August 1995 onwards, if we don't get that exact match with the database, we are still going to carry on and do a full catalyst test. And that we'd use things called default limits. Now the default limits are in your tester's manual and they're also in the Department of Transport's emissions handbook. So what we've done is we've followed the flow chart along. The flow chart's asked the same question, is it a passenger car? This one clearly is. Does it exactly match the database? If the answer is yes, you do a catalyst test and use the machinery. If the answer is no, it doesn't exactly match, you still use a catalyst test, but now use the default limits.
Now this one's got a personalised number plate, so what do you do then?
Well, clearly, because there's no way we can tell the vehicle's age, we'd need the registration document or other evidence of the date of first registration to be able to fit it into one of those age groups or slots. We'd need to know which one to use.
Now you've said that there's different tests for different age groups of petrol vehicles, but does the same rules apply to diesels?
Yes, they do, Sean, but fortunately this time there is only one date to remember. And it's for, here I've got a diesel vehicle here. This is a fairly modern one. But if a diesel vehicle's registered before the 1st of August 1979, it would receive what we call a visual only test. The first thing we'd have to do is to make sure the engine's hot. Now the way we do that is to use the approved diesel temperature meter and measure the oil temperature, which has to be above 60 degrees Celsius. That's also a good time to make sure there's enough engine oil in there. Once the engine's warm, we're going to purge it for 20 seconds at half revs, let it drop back to tick over, and then go and look at the smoke emitted from the tailpipe. When we've done that, we're then going to blip the throttle from tick over to half revs to see if there's sufficient smoke to obscure the vision of other road users. But with this more modern vehicle, this would have a machine test, and I'm going to take you later and show you how that's done.
Now, you've mentioned with some of the more modern petrol cars, but how actually does a catalyst work?
How does a catalyst work? Tell you what I'll do. I'll take you and show you. Here's a section catalyst I've taken from our training room. There are several types of construction. This particular one is known as the ceramic honeycomb. The purpose of the honeycomb is to give the maximum possible surface area over which this chemical reaction can take place. That honeycomb would be coated in rhodium or platinum, a very precious metal, so it's an incredibly thin coating. The purpose of that is to take the toxic and harmful gases coming in, a chemical reaction takes place, and there's much less harmful gases come out of the end. So this chemical reaction has several controlling conditions that must be right, otherwise this won't work. Now, one of those conditions is that the catalyst must be hot enough, and in the trade we use the term, is the catalyst lit or lit off? Now, the light-up temperature for this catalyst is approximately 600 degrees Celsius, so you can see that's pretty seriously hot. In addition to is it hot enough to light, there's another major factor, and that is that the catalyst can only work efficiently and effectively when it's dealing with exhaust gas which has been burnt at one particular mixture of air and fuel. And that mixture is 14.7 to 1. So 14.7 parts of air to 1 part of fuel burnt in the engine. Exhaust gas burnt as a result of that mixture can be effectively and efficiently cleaned up by the catalyst. Any other ratio, richer or leaner, and this ceases to work effectively. And so we have to have a means of controlling the engine in that band, and we call that the closed loop. Now, the thing that makes the closed loop work is just upstream of the catalyst here is an oxygen sensor, or people tend to call it the lambda sensor, but it's actually sensing how much oxygen remains in the exhaust gas mixture. Having measured that oxygen, it then sends information to an ECU, that's an electronic control unit. The electronic control unit tells the fuel injection system how much fuel to put in the engine. And so by means of this closed loop, sensor, ECU, fuel injection, we make the engine stay at 14.7 to 1. Now, the term we give that is lambda. So 14.7 to 1, lambda 1. And that's something that comes into the catalyst test. When you're doing the catalyst test, you're looking at CO levels, you're looking at hydrocarbon levels, and you'll be checking to see that the engine is maintained at or very, very close to lambda 1. So let's go and look at the closed loop system. Let me start by identifying the components we talked about up the top. First of all, here's the catalyst unit itself. Then here's the front exhaust pipe. And here's that oxygen sensor or lambda sensor with its control wire. And now let's have a look at the closed loop. So remember that the catalyst can only take care of gases burnt as a result of 14.7 to 1 air fuel mixture or lambda 1. The oxygen sensor, that measures how much oxygen has remained in the exhaust gas, and it can work out what the engine's running at. It sends instructions via this wiring to the ECU, the engine control unit. The ECU controls the engine mixture and makes sure that the gases entering here are at lambda 1. The catalyst can then control and clean up those gases, and there you have it. That's as simple as that, your closed loop. I think the thing to do now is to go off to the test station and actually test this system and see it working. I'll take you through an emissions test on this vehicle here. The registration date is easily identifiable from the number plate. We would now take the age of the vehicle and, knowing the age of the vehicle, work along the flow chart in the tester's manual. Working along the flow chart, we'd end up on this page and make a series of yes and no decisions. I've already examined this engine, and we can find an exact match of the engine code with the database on the equipment. And therefore we'll end up in this area here where the book tells us to carry out a catalyst test using database levels. As I said, I've already prepared this vehicle, but one or two of the problem areas can be these. It may not be possible to measure engine oil temperature, and the tester's manual gives us instructions on how to overcome that problem, to bypass that. Likewise, if there is a difficulty measuring engine speed, there is the option for bypassing. These should only be used when it cannot actually be connected. The other possible problem area is actually finding and identifying the engine code. This is critical. It must be an exact match with the database, and we've done it with this vehicle. So now we're ready. I've already entered the vehicle details, so we'll run through the test procedure. Now everything that we're asked to do comes up clearly on screen. Our assistant Eric has inserted the probe in the tailpipe and is now sitting in the car waiting to operate the throttle for us. Eric, by the way, is just assisting us for the purpose of the video. All the next instructions should clearly come on screen, and it's asking us now to raise engine speed. Eric, please raise the engine speed to within the operating band. Now this is the first fast idle test. The catalyst must be hot and lit. If it is, this will quickly accept the readings which are displayed on the screen and drop us into what is then called the catalyst stabilisation period. And we'll see this, yes it has, the cat has done its job, we've accepted the readings, and we're asking the catalyst if it stays lit in catalyst stabilisation. So there's a countdown period on the screen here, and we have to hold it there until that countdown comes back to 0. If the first fast idle test fails, all machines will require you to maintain the revs for up to 3 minutes before the machine will do a second test. At the end of this period, it will ask us to return to a natural idle. Eric, back to idle. And there's a 10-second countdown to let tickover stabilise. When tickover is stabilised, the machine will measure the CO at what's called natural idle, and it will also measure that this engine idles at its specified limits, and the manufacturer's limits are in this database here. So there we go, there's the natural idle. It's clearly in the acceptable band, and it's telling us the test is completed, and it's that simple. Remember, this equipment makes 2 copies, one for the customer and one for your records.
Sale of diesel cars over the past few years have mushroomed, and they too need to meet emission standards.
Right, Sean, I'll take you through the metered smoke check procedures. Now, the procedure actually starts way back in reception, where the customer should have been asked the 2 questions. Has the cam belt been changed at the correct intervals? Has the engine been serviced in accordance with the manufacturer's recommendations? We must have got positive answers to both of those, otherwise we wouldn't be here. So now we're at the vehicle, we're going to do a series of pre-checks. The first of those is to ensure that the meter can actually fit into the tailpipe. It must actually be able to insert there. The second one is coming forward to the engine. We're going to make sure that there's sufficient engine oil in and that there's no indication of low oil pressure. And the only reasonable way of doing that would be observing the oil pressure warning light having gone out. The next thing is to do the cam belt checks, where these can be seen. Now this must be without the use of tools, and an engine such as this has thumb clips, and we'd bring off the thumb clips, carefully ease back on the plastic cover, and that would be sufficient to give us a glimpse of the cam belt. Now this cam belt is checked for 3 things: contamination, damage and slackness. Now this cam belt is clearly not contaminated, and that would be by water, coolant, oil or fuel. It's not damaged, although we can only see the back of the belt, not the teeth. It looks in good condition, and we'd try wherever we could to see if it was obviously slack, and this one's nice and tight. So we'd replace the cover and the clips. Remember, as I said, if there were tools required, you wouldn't be able to perform that particular check. Having done the cam belt, the next thing is to look for things like engine defects, and that involves looking at the tailpipe to see if there was excessive white or blue or black smoke. All of those indicate engine defects, and with an engine defect you should not carry out the diesel test. listening to the engine running. If there are any unusual noise or rattles or bangs, things that you thought didn't belong in that engine, again, these are reasons for refuse to carry out the diesel test. Once we're happy with those, we're then going to, using suitable engine temperature measuring equipment, coupled to the equipment, we're going to measure engine oil temperature to ensure that it's above 60 degrees Celsius. We're required to check that the governor seals have not been tampered with. And in this particular case, the fuel injection pump and the governor seals are beneath this plastic cover, and that's a bolted cover, so we simply can't view them on this engine. But where they can be viewed, they must be viewed. And if they have been tampered with, that actually isn't a reason to refuse to carry on with the test. It's a reason to be very cautious when, in a moment, in 2 steps' time, we're going to perform the governor test. And if the seals look as though they've been tampered with, we should be ready for the engine either over-revving or under-revving. So the governor seals have been viewed where possible. We're now going to purge the engine by running it at half revs for 20 seconds. At the end of that 20-second purge, we will slowly take the revs right through to maximum. This is the governor check, and we're actually listening or watching if the engine is fitted with a tachometer. And we're listening or watching for the engine governor to cut in. Revs are going to rise up, peak and flatten off, and we should be able to hear that happening. And as I say, if governor seals had been tampered with, we'd be a bit cautious about that. When we've done that, we allow the engine to return to a natural idle, and we start to connect up the equipment ready for the test, following the manufacturer's test procedure from his handbook. This particular equipment I've got here would require us to start off by measuring engine oil temperature. Now, it's ideal to start the engine before we start to insert the probe. Let's go through the procedure with the equipment. The first thing we're asked to do is to measure engine oil temperature. I've already set the length of dipstick, and we're going to take a temperature reading. This temperature reading for all diesels must be above 60 degrees Celsius. As soon as we're above 60 degrees Celsius, we'll lock in that temperature and remove the equipment replacing the dipstick. We're now asked to insert the pipe, and Eric's going to put that in for us. So Eric, if you could slip the pipe in, please. Tell the machine the pipe's in. We're ready for the revs. Okay, Eric, pull it on. And on. That's an acceptable reading which I've locked in. Okay, Eric, if you could remove the probe, please. And we'll take a final print. What the machine has done there has taken an average of the last 3 accelerations and produced it on the screen. Now, those levels will depend on whether the engine is turbocharged, as this one is, or non-turbocharged. And for the particular levels, refer to your current tester's manual. With this particular type of equipment here, the tester needs to know what the levels are before he actually does that, because this machine doesn't tell you whether you've passed or failed, it simply tells you what the average is. So you need to be ready and know whether the readings are acceptable. If they were unacceptable, then you would repeatedly carrying on those accelerations up to a maximum of 6. Once the 6 accelerations are completed, if the average of the last 3 are still not within the known acceptable level, then the vehicle would have failed. Sean, there are issues here that involve all vehicles, petrol and diesel, and it's this. Now, emission testing should be conducted in a well-ventilated atmosphere. or alternatively by using suitable exhaust extraction equipment like this. Exhaust extraction equipment must not be attached to the tailpipe, and therefore equipment like this that can catch the exhaust fumes, this sort of equipment should not be placed closer than 250 millimetres so that we can work in this well-ventilated atmosphere and we're not polluting the workshop. Now, with diesel engines, even if they pass the metered test, there is a further requirement the tester must assess, and that is whether it's emitting excessive smoke or vapour of any colour likely to obscure the vision of other road users.
As well as road safety, the Vehicle Inspectorate is committed to environmental protection for everyone, and a major part of this is the emission testings of vehicle at MOT time. Without doubt, the future is going to mean more vehicles on the road and more pollution if things continue the way that they have been in the past. And it's up to every member of the vehicle using public to ensure that the vehicle is running as efficient a manner as possible.
We all want a clean environment, and there are a few more graphic illustrations of the difference low emissions can make than this.
This is Mexico City on a weekday, and this is Sunday morning. Now you can see the mountains. MOT Matters is a series covering many issues that concern authorised examiners and nominated testers. An address for more details and where to order further titles is on the back of your video case.